In this video, we will be investigating Boyle's law using the Go Direct gas pressure sensor. The primary objective of this experiment is to determine the relationship between the pressure and volume of a confined gas. The gas we use will be air, and it will be confined in a syringe connected to a Go Direct gas pressure sensor. When the volume of the syringe is changed by moving the piston, a change occurs in the pressure exerted by the confined gas. The pressure will be recorded as a function of volume on the Graphical Analysis software. From that data, you should be able to determine what kind of mathematical relationship exists between the pressure and volume of the confined gas. The Go Direct gas pressure sensor can be connected via USB or via Bluetooth to your platform. Platform can be a Chromebook, Mac computer, Windows computer, iOS, or Android device. To get started, make sure you have downloaded the free Graphical Analysis 4 app from our website or the appropriate app store. Since I will be taking data via Bluetooth, I will first turn on my pressure sensor. I then open my Graphical Analysis 4 app and select Sensor Data Collection. I connect to my gas pressure sensor and select Done. For this experiment, I want to be able to tell the software what volume my syringe reads. This requires a mode we call Events with Entry. To set up my data collection, I tap on the Mode button. Then from the drop-down menu, select Events-Based. Make sure Events with Entry is selected and change the event name to Volume with units of milliliters. And select Done. Now that my software is set up, I want to prepare my pressure sensor. I take the syringe that ships with my pressure sensor and set it to 10 milliliters. I then connect the syringe lure lock to my gas pressure sensor lure lock and make sure they are finger tight. I'm now ready to collect data by pressing the Collect button. No data is recorded until I hit the Keep button. My live pressure reading is in this corner and it is currently stable. Once I press Keep, the data point is recorded and the software is asking me to tell it what the volume that pressure corresponds to. Now the syringe is reading 10 milliliters. However, there is 0.8 milliliters of volume inside the pressure sensor that I also need to account for. So for every value I type in, I will need to add 0.8 milliliters to it. So this volume is 10.8 milliliters. Press Keep Point. And now that data point is recorded. Now I'm going to move the piston to 5 milliliters and press the Keep button. I can now relax the piston and type in 5.8 milliliters for that data point and keep point. I'm going to repeat this process for several different volumes. Next, I will do 7 milliliters. Press Keep, and that is 7.8. Now I'm going to do 12 milliliters. Keep. 12.8. And finally, 15 milliliters. Now I can stop data collection once all my data points have been collected. In looking at the data, we should be able to determine whether the mathematical relationship between pressure and volume is direct or inverse. We can check our educated guess with the curve fits built into Graphical Analysis. To do that, we click on the Graph Tools icon and tap on Apply Curve Fit. Linear is the default, but we want to select the power fit and then click anywhere on the graph to get the data parameters. The power value, B, is very close to -1. This confirms that it is an inverse relationship. To further investigate the type of relationship that exists between pressure and volume, a graph of pressure versus the reciprocal of volume can also be plotted. To do this using graphical analysis, it is necessary to create a new column of data, reciprocal of volume, based on your original volume data. First, I want to remove the fit, and then tap on the dots in the volume column and select Add Calculated Column. I want to rename my calculated column to be 1/volume with units of 1/milliliter. To enter the correct formula for the calculation, select Insert Expression and select A/X. Make sure parameter A is 1 and column X is volume. Select Apply. Make sure that 1/volume is displayed on the horizontal axis. If the relationship between pressure and volume is an inverse relationship, the plot of pressure versus the reciprocal of volume should be direct. That is, the curve should be linear and pass through your data points. Let's perform a linear fit on this data to see if that's correct. From the Graph Tools icon, select Apply Curve Fit, and it is indeed an inverse relationship. For more information about the Vernier Go Direct gas pressure sensor and our Go Direct line of sensors, visit our website or email info@vernier.com.